Good day, friends. We'll continue from where we stopped in the last class. Remember that in the last class we stopped here. We dealt with operations with logarithms which are negative. So this is what was covered in the last class. And we really did justice to this in the last class. If you missed that class, you can go back and watch that video. Now we'll continue from where we stopped in the last class. We're actually dealing with the same topic and we'll forge ahead. Let's deal with more examples. So further examples. So evaluate the following. Leaving the answers to three significant figures. As 0.00974 times 8.065. B. We have 32.48 times 2.03467 and 0.00897 and 0.9458. Then C, we have this 8.75 divided by 0.0084. So let's solve this. Solution, the first one we have this, we have to simplify this 0.00974 times 8.065 as we have stated there. So you can use any method of your choice. Let's use this one. Create a table, the number and the log. The first number is 2.00974. Check the logarithm table based on what we have been doing. You know that if you do the same thing, you have to get by 3.9886. Can go and verify. Let's save our time. 8.065. You add up, you have 0.9066 as a logarithm. Then you add up. You know why we're adding up? This is multiplication. We say we add up the powers, right? Adding up, remember how we add up? 6 plus 6 is 12. We'll put down 2, carry 1. 8 plus 6 is 14. Plus that 1, 15. Put down 5, carry 1. 8 plus 0 is 8. Plus that 1, 9. 9 plus 9 is 18. Put down 8, carry 1, right? Now, by 3, which is treated as minus 3, plus 0, we're adding the characteristics now. By 3 plus 0, it remains by 3 minus 3. Plus the one you carried the other time. Minus 3 plus 1 is what? Minus 2. How did we get the minus 2? We have done justice to this. You can go back to the previous video. So we have about 2 points this as our new logarithm after addition. Now you find the antilog. How do we find the antilog? Treated in the last videos. You can watch the previous videos. You have 0.07856 here. So it is straightforward. You don't have to spend much time on this. You have done justice to this before. So this is the first one. Now let's see the second one. Second one says, by the way, you can express it to 3 significant figures. These that we have here, these are our answer if you are to express in two singular figures, that is to say that we have 0.00786, so three significant figures. Now, you can rough check. If you have to rough check, what do? You see that this is approximately 0.01, right? If you approximate, it's 0.01. Let's say rough check. Since it's approximately 0.01, if you round it up, we have 0.01 times what? This is approximately 8. So let's say times 8. If you punch your calculator, 0.01 times 8 is going to give you something similar to what we have here. This is 0.08, right? And you see this is a very close value to 0.007. This is 0.0786. Sorry, it should be 0.07. You know that. So you see it is approximate value to this, like we have here. Right. Let's take the next example, which is B. The next one is 32.48 times 0.03467 times 0.00897 times 0.9458. So that's what we do here. I prefer to work with the tables. So let me work with the tables solution. You can do your own the other way, the other method I taught you, no problem. Depending on the one you want to familiarize yourself with, or the one you want to work with. If you have to simplify this one, the logarithm of this one is 1.5416. Then if you have to find the logarithm of 0.03467, the logarithm is about 2.5400. To find the logarithm of 0.00897, the logarithm is about 3.9528. We are saving our time. You can confirm this yourself. Then if you have the logarithm of 0. If you want to find the logarithm of 0.9458, your answer will be about 1.9758. If you do this, you notice you have about 3.9802. That is after summing up everything. You notice multiplication. So it means you are simply adding up all the logarithms you obtain here to get this. And then when you find the anti-log, remember you always look for the anti-log. You have 0.009554. Right. Now, that is to say that we have 0.00955 if you have to express it to three significant figures, right? How do you check this? You see, this is approximately 30. Let's just say 30 times. This one is approximately 0.03 times. So this one is approximately 0.009, right? 0.09 times what again? This one is approximately 0.9 for round of 4 times 0.9. Well, that will be equal to what? If we simplify this, it's going to give us 0.00729 as we have it here. Now, you see this is similar. So what we have here, you notice that our answer here is similar to what we have here. You get it? And you may say, well, it is 0.009, blah, blah, blah. And this one is 0.007. Why is it like that? When we're rounding up, we ignore some digits, right? Those figures we ignored affected what we have here. But if you consider the rough check, you see that it is similar to what is there. That's one way you confirm that what you did is actually correct. So let's try this one. This one is division. C. Next example. We have this. I have 8.75 divided by 0.0084. And you know it can also be expressed in this form. 8.75 all over 0.0084. That's what it simply means. So creating our our log tables, we have the number and the log. We have 8.75 as our first digit. The logarithm is 0.9420. Also have 0.0084. We have bar 3 as our logarithm, 9243. You can check previous videos. This time around, are we adding up or subtracting? Of course, we are subtracting the powers. Why? Because this is division. The rule says when it is division, you subtract. So let's subtract. So to subtract, using the power of subtracting, we know that we are going to get 0177 here. How did I get that? You know 0 minus 3 is not possible. You borrow 1 from here. 10 minus 3 is 7. You know when you borrow 1 here, it becomes 10. 10 minus 3 is 7. Here we have 1 left. Borrow 1 here. Since we cannot subtract 4 from 1. So what we have 1 here, you borrow 1 from this place, it becomes 11. 11 minus 4 is what? 7. What do we have here? 3. 3 minus 2 is 1. 9 minus 9 is 0. We have a point here. This is 0 minus bar 3, which is 0 minus 3. I told you 1 minus and minus. When two signs come together, they multiply. And minus times minus is plus. So 0 plus 3 is what we have here. 0 plus 3 is what? 3. If you add 0 to any number, what you get is that number. So here we have 3.0177. Find the antilog of this, you will get 1042. How did we do it? Go to logarithm table, find the numbers whose logarithm is corresponding to 0177, and you will get 1042. And then you know the characteristic is 3, it has to reflect here. I have 0, 1, 2, 3. So the decimal points will be outside. That implies that we have 1040 to 3 significant figures, right? Good. Now, there's an alternative way of doing it if you want to avoid notation. That is to say that those decimal points you want to reduce working with decimal points. How do we do that? Let me give you another method. Alternative. Or you can call it method 2, anyone you want to call it. To avoid the bar notation, we multiply the numerator and the denominator by 1000. So that is to say that let me see. You can multiply the numerator and the denominator by 1000. That is just to avoid the bar notation. To avoid bar notation. So this is what I mean. That implies that this 8.75 all over 0.0084, you can simply multiply both the numerator and the denominator by 1000. The fact is that if you multiply both the numerator and the denominator by 1000, you haven't actually altered the value of the number. As far as the fraction is concerned, the fraction is still the same. It is only when you multiply one of the fractions, ignoring when you multiply either the numerator or the denominator, leaving the other one, that you alter the fraction. But since you multiply both numerator and denominator, the fraction is the same. And then this time this is going to give you 8750. You know how we do this with our calculator. Refer to previous videos. Now here we have 8.4. See that? So we can go ahead and create our table now. We have a number and log. Here we have 8750. We have 3.9420. You can press a calculator. You can go to your logarithm table for verification. For 8.4, we have 0.9243. We are subtracting. Why are we subtracting? Because the question is according to division. Look at it. Say this divided by this, and that means the logarithm is going to be subtraction. We use subtraction to solve them. So what becomes our answer? Of course, after solving, you will notice that your answer is the same answer we got earlier. You can verify. So this is 1042, which is 1040 when rounded up to 3 significant figures. Right? Next example. What do I call this example now? I call this, okay, ABC, right? So we have done this. Okay, we have done this. And let's take more examples. Let me see this one. More examples. Now evaluate. This one is quite different, but we have applied the same rules we have been applying. It's only looking more complex, but it's as simple as the rest. 80.67, that is more or less, times 0.008692 all over 0.09468. Let's solve this one and see what we are obtain here. Now, as usual, get your number, log, for 80.67, you get 1.2711. The logarithm table for 0.008692, you're going to get about 3.9391. If you add this up, we have to add, right? Yes. Why are we adding? Because this is multiplying this. You get by 1.2102. See the logic. Now remember, this is the numerator only. We are simplifying gradually. we have found a common logarithm. That is, we have simplified the logarithm for the numerator. So the whole of these, their logarithms, this and this added together, we get this, right? Now let's go for the denominator. The denominator, which is 0.9468, its logarithm is about 2.9763. You see that? We simplified the logarithm, we simplified the numerator first. That is, we got their logarithms, added them together, and we got this, which is the numerator. Now we are dealing with the denominator. We found the logarithm of the denominator, which is this. You see it now. Now, what are we supposed to do? We are to subtract. Why are we subtracting? Because the whole of this divided by this, we are dealing with a logarithm. It means we have, since the whole of this is this result, we have this minus this. Because this is the logarithm of the denominator, while this is the logarithm of the numerator. And you remember that when we have a fraction like this, for example, a over b, you are looking for their logarithm. What we do is that we subtract the logarithm of the denominator from the logarithm of the numerator. So since the whole of this is the fraction, we got their logarithms and obtain this logarithm. And the whole of this is the logarithm for the entire numerator that has been obtained here. And this is the denominator. And we know that denominator is divided the numerator. It means we have to subtract the denominator from the numerator. You understand now? Now, let's subtract. If we are to subtract, our answer here is going to be 0.2339, right? Yeah. 2 minus 3 is not possible. If you borrow to this place, 12 minus 3 is 9. Remember, you borrowed to this place before, so you now have 9. Okay, let me take time to explain this a bit, although this is primary school explanation. 2 minus 3 is not possible. Try to borrow from here. But this is 0. You can't borrow from here. Jump here. This is 1. Can you borrow from 1? Well, if you borrow from 1, that will be, it means we have 0 left here. We borrow it to this place. It comes before this 0. It becomes 10. Now, borrow from this place to this place again. Here reduces to 9. And here we have 12. Now, 12 minus 3 is 9. Here we have 9 left. 9 minus 6 is 3. Here we have 0. 0 minus 7 is not possible. So you have to borrow from here again to this place. It becomes 10. 10 minus 7 is 3. What do you have left? 1. 1 minus 9 is not possible. Right? Is it possible? No. How do we do it? You bring 1 to this place, making it 12. Isn't it? It shouldn't even be 12. It should be 11. Remember, we borrowed 1 from here before. So what we have here left is 1. Right? Now, if you bring 1 from this place, 1 minus 9 is not possible. Bring 1 from this place to this place. Comes behind it, it becomes 11. 11 minus 9 is 2, right? Now, that's what we have is 2. Remember, this was bar 1 before you borrowed. Now that you have borrowed, it means we have bar 2 left. So, we have bar 2 minus bar 2. That is minus 2 minus minus 2. And that is minus 2. Minus times minus is plus. Minus 2 plus 2. Minus plus this was 0. I'll get it. Right? As simple as that. My explanation here, if it seems vague to you, I was too fast. Well, just refer to previous videos. We've done justice to this, so there's no need spending much time here. You have some exercises here. Use logarithm tables. Use logarithm tables to evaluate Use logarithm tables to evaluate the following to three significant figures and check the answers. 1. 4.986 times 0.0678. 2. We have 0.00892 times 0.6798. 3. We have 97.08 divided by 560.5. And 4. We have 3.89 times 97.76 all over 867.5. Right? So let's just stop here. Or you can still work with this. Let me give you one more. We have 3.37 times 0.000000, yeah, 74 divided by 0.03795. So you go back to the answer page, get the answers. Here you have the answers available here as presented in the textbook. So these are the exercises. You try them. These are the corresponding answers. Number 1, you're expected to have this as your result if you get it correctly. 2, 3, 4, 5. I trust those answers that they should be correct. So you can go ahead and do them, then verify. Thank you. In our next video, we'll be considering the subtopic powers and roots of numbers. Powers of roots of numbers less than 1. See this, we'll be considering this. This will be our next subtopic. Thank you for watching. Be sure to follow, subscribe to promote our page. My name is Lucky Wajiro Jumbo. I have the interest of teaching science subjects here, ranging from mathematics, further maths, physics, and chemistry, dealing with all topics as far as O-level examinations are concerned, the preparation for exams like WAEC, NECO, JAMB, BC, and all of that. If you are an undergraduate or even a graduate, and then for any reason you see the need to come back and learn some of these things, you can as well help yourself by following my page, and you help me by promoting my page too. I appreciate that very much. Concept here clearly explained. If you have questions, feel free to ask your questions. Drop your questions in form of comments at the comment section, and I'll likely get back to you. Thank you very much. So see you next time. Expecting you where we'll be dealing with powers and roots of numbers less than 1. God bless you.